going to be talking about log derivatives today, which are some of my favorite. So real quick, I have some of the basic log rules above. So first, if you take the derivative of the natural log, that's going to equal 1 over x. Now, if you take the derivative of the natural log of something else, so you have a function on the inside, well, that's going to be 1 over that inside times its derivative. Now, the same rule applies if you're doing a log in a different base. So, for example, log base a of x equals 1 over the natural log of a times x. So, if the inside is actually a function, then that is going to replace that x on the bottom, and then you multiply by its derivative. So let's just jump right in and start looking at some examples. Let's go crazy. So let's find the derivative for the following functions, 1 through 6. So first, the derivative of this guy is going to be 5 times the derivative of the natural log of x, which is 1 over x. That's your answer. You can also rewrite it as 5 divided by x. Same thing. All right, the next one, log base 5 of x. So that's going to be 1 divided by the natural log of 5 times x. All right, and that is using this rule right here. Now for the next one, we want to find 20 times log base 4 of 3x. So this is our inside function, so we just have to be aware of that. So we're going to have 20 times the derivative of log base 4 is going to be 1 over the natural log of 4 times, so our inside function, f of x, is 3x. We're just going to be times 3x times the derivative of the inside, which is 3. So remember, the chain rule says you take the derivative of the outside, leave the inside alone, and then multiply by the derivative of the inside. Now we can clean this up a little bit. Those 3's are going to cancel. So it would be 20 divided by the natural log of 4 times x. All of that's on the bottom. All right, now for the next one, well, we have the natural log of this whole inside plus 3x. So we're taking the derivative of this piece. So the derivative of the natural log of the inside is 1 over whatever the inside is times that derivative of the inside. So the inside derivative is going to be 4x minus 1. Plus, now since we're adding, we don't have to do any chain rule or product rule, quotient rule. We just have to take the derivative of this guy, plus 3. So here again, what we did is that we just divided by that f of x on the inside and then multiplied by its derivative. Okay? So if we scroll back up, we can see that you leave the inside alone and then multiply by its derivative. Multiply by its derivative, just using the chain rule. Ooh, this next one's going to be fun. So, on this next one, we're taking this whole thing and raising it to the 4th, and then we're taking the derivative of the natural log, and then we have another inside. Ooh, so what this is this is a turducken of taking derivatives. So, first we're going to take the derivative of the outside. What do you do to the inside, y'all? That's right, leave it alone. So we're going to leave the inside alone. Times, now we're going to take the derivative of the next inside. So remember, the derivative of the natural log is always going to be 1 over the inside, so 3x plus 2, divided by x squared minus 5. So remember, it's always 1 over the inside, times, and we have one more, the derivative of that inside piece. So the derivative of that inside piece would be the bottom times the derivative of the top minus the top times the derivative of the bottom. Oh no, I ran out of room. all over the bottom squared. Alright, let's go ahead and clean this up just a little bit because it looks super, super gross. So that's going to be 1/4 natural log 3x plus 2 divided by x squared minus 5 to negative 3/4 times. Now this guy, if you're dividing a fraction by a fraction, you can actually flip it upside down and it's going to be the same thing. Times, now that top part is going to be x squared minus, or I'm sorry, 3x squared minus 15 minus 6x squared minus 4x all divided by x squared minus 5 squared. Now I'm going to clean up the top just a little bit so that top can be cleaned up. That would be negative 3x squared, whoops, minus 4x minus 15. Okay. Alright, so that top part isn't going to factor, but what I do know is that this piece and this piece, I can cancel one of those out. Okay, good. So that simplifies into this piece, which still doesn't look very nice, but hey, we did a great job. Alright, and finally, on number 6, we are going to have the inside piece right here. Whoops. We're going to have this inside piece. So remember, the derivative of the natural log is going to be 1 over the inside left alone times the derivative of the inside. So since these two are being multiplied together, we're going to have to use the product rule. So we're going to have 3x squared times the square root of x plus 1 plus x to the third times 1/2 x plus 1 to the negative 1/2 times 1. Okay, great. Now we can simplify this out a little bit. When you're doing this on an exam or something, I'm totally cool if you just leave it like that. However, I do know that StatCrunch can be pretty picky. So let's go ahead and try to make this look a little bit nicer. I'm going to take this and I'm going to FOIL it. So I'm going to multiply it by each of those inside pieces. So that's going to give me y prime equals 3x squared times the square root of x plus 1 divided by x cubed times the square root of x plus 1 plus, now this guy, because that's a negative exponent, I can actually toss it on the bottom. So that's going to be x cubed divided by 2 times the square root of x plus 1. So because, again, that's negative, I can put it on the bottom, and that 1/2, that 2 can go on the bottom with it as well. Okay. So, oh, you know what I forgot to do? I forgot to multiply this times x cubed square root of x plus 1. So let's start looking and see if things cancel. So that's going to cancel with 2 of those and leave a 1 there. These guys are going to cancel. That's going to cancel with that. So what I'm actually going to be left with is 3 plus 1 over 2 times x plus 1. The x plus 1, if you multiply 2 square roots together, the square roots cancel. So that would be the same common denominator before we can put these together. So we're going to multiply this one by 2 times x plus 1 over 2 times x plus 1. So what that's going to give us is that's going to get 3 times 2 times x plus 1 plus 1 all over that same common denominator of 2x plus 1, which, let's see, so that'll be 2x plus 2 and then times 3, so that'll give us 6x plus 6 plus 1. So what we should end up with on the top, whoops, is that should simplify out to 6x plus 7 divided by 2x plus 1. So I know that's a really long way to go, but just again, because StatCrunch can be persnickety and I want you guys to get good scores, that's how you do that. Alright, we have 2 more and then we're going to be done. So we want to show that these result in the same derivative. So for the first one, let's go ahead and take the derivative. So that would be 1 over x minus 1 over x minus 1 times the derivative inside, which is just 1. So that would be 1 over x minus 1 over x minus 1. Now we should combine these. Okay, so again, we're going to multiply them by each other's denominators so we can get a common denominator. So when we do that, we're going to have x minus 1 minus x divided by x times x minus 1, which x's are going to cancel out, so we're going to end up with negative 1 over x times x minus 1, since we found a common denominator. Now for the next one, you take the derivative, we're going to have 1 over x divided by x minus 1 times, now we have to take the derivative of the inside, so that's going to be the bottom, times the derivative of the top, minus the top times the derivative of the bottom, all over the bottom squared. Now what I can do is that I can take this piece and rewrite it by flipping it upside down, so it would be x minus 1 divided by x times, now if I simplify this side, I'm going to have x minus 1 minus x divided by x minus 1 squared. Now the cool thing is that that is going to cancel with one of those guys. These x's are going to cancel out. So we are going to get negative 1 divided by, and then the bottom is going to be x times x minus 1. So we get the same answer, and that's by properties of logs. Alright, now the very last one says that the total revenue in dollars from the sale of X units of a product is given by this. We want to find the marginal revenue function, and then find the marginal revenue when 100 units are sold and interpret our result. So, first, we have to find the derivative. Remember, the derivative of the revenue function is the marginal. So it's going to be the top times the derivative of the bottom remember, the derivative of the natural log of 10x plus 10 is going to be 1 over the inside times the derivative inside minus the bottom times the derivative of the top, which is just 2,500, all over the bottom squared. Good, now it still looks kind of gross, but that's okay. So for part B, what we are going to do is to find the marginal revenue when 100 units are sold, is you're going to plug 100 into that derivative function. Okay, now what that's going to do is that's going to tell you the revenue for the 101st item sold. So I'm going to go ahead and let you guys do that. Alright, I hope this video helped you out. I will see you guys later.